evening, everyone. So here we have seen the different ways how to override a method, different rules of overriding method as well. So always method overriding is possible in the inheritance concepts. We cannot write or we cannot use overriding concept in a normal class. Remember that. Okay. We have already seen the difference between method overloading and method overriding. In the last session, we were trying to see the upcasting and downcasting concept. So we are going to complete that part now.
Ma'am, at override is an attribute, right? The property which we have to add it before the method. It is not like a word which we are attaching it for the function declaration.
No, I don't understand your question, Jyoti.
No, because at override, you have written it before the function, right? You can just open the program. So what exactly that is called as? Is it an attribute? It is a property.
No, it is known as annotation.
Annotation. Okay.
I will
So
try.
we are not writing this override keyword for this public double override get rate of interest method, right?
It is added only for the overridden methods.
Okay, so if I'm using the same function name, automatically it gets added.
Yes, it is. It will get added automatically by the Eclipse. But if you are writing a program by yourself,
Notepad or other things,
anything, any other ID,
editors,
you can add it. It is not compulsory to add this. If you are removing it, or you can skip that overriding annotation. It is just to understand that this is an overridden method.
Okay.
While going through this program, most of the time, what happens if the method names are same as we have written this program in a single Java file, right? So sometimes what happens, we never understand that this method is overridden.
Correct.
Right. So just to clarify that, or just to simplify the whatever program you are writing, we can add this annotation, override annotation, so that you can immediately see this part and you can immediately get it that this is an overridden method.
Okay, fine.
So it is not compulsory to write. You can skip that also. When you are writing that code into Notepad or any other IDE, you can skip that part also. Okay, no problem with that. But here in the Eclipse, it is automatically gets added. If I am trying to skip it, it will always add it again. Okay.
Yeah, because in other technologies, I have seen like override keyword, we are adding it. Whether it is a C++ or Java or other things, sorry, .NET, other things, we are adding that override word within the function.
Okay. But here we use this annotation just to understand that this method is overridden method.
Okay, fine. Thank you.
The function of that annotation is only for that to understand this method is overridden from the parent class, nothing else. It is not performing any operation. It is not going to perform anything. So all the annotations, there are multiple annotations. So when you create any class and you are trying to add some notes, okay. So we use this annotation author. We'll show you that. At the rate. Author is the annotation. You can add author name. You can give other annotations also. There are multiple annotations basically in Java. This is for documentation purpose. Okay, so when you open any documentation on the website, so that it will show all these details in a proper way. Okay.
So these annotations are not mandatory and automatically JVM will add behind the scene.
It is not automatically added basically. For this override, it is automatically added by the Eclipse. Okay. It is not added by the compiler. If you want, you can add it.
Okay. So as you told, like other annotations are also there.
Yes, there are multiple annotations. You can see here. You just have to place the
So these need to be added by us only.
Yes.
Separately. Okay.
These are for documentation purpose.
Okay.
Okay, coming back to the current point, that is upcasting and downcasting concept. So here we were seeing that upcasting concept. Just like data type casting, we have seen the type casting concept, right? So we can cast from lower to higher data type. From integer to double, we can cast. From double to integer, it is possible, but that gives some problem. It may lose some data because of narrowing and widening concepts in the typecasting. We have already seen that. So this is similar to that. It is typecasting only, but it is related to objects. We are casting objects here. Okay. So typecasting of objects basically means that one type of object, that is child or parent, to another. Okay. It is always possible in the parent-child relationship. That is nothing but into inheritance. So there are two types of typecasting. First one is upcasting and second one is downcasting. Upcasting, we have already seen one of multiple examples up till now. That is typecasting of a child object to a parent object. So basically when the child we are casting into parent, when we create parent object and we are initializing it through child reference, that is nothing but the upcasting concept. We, in the last example also, we have created one object that is bank B, and we are initialized it through SBI, right? So this is an upcasting. We are casting child object into parent object, right? As you know that when you are creating parent object, you can access only parent members. You cannot access child members. Second one is the downcasting. Similarly, downcasting means the typecasting of parent object to a child object. But in Java, downcasting is not implicit as well, and it is not supported in Java. Okay, so downcasting is not supported in Java. Why? Because basically this inheritance is a relationship. Okay, child is always a parent. That means in our example, we can see that SBI is a bank. Okay, you can say that SBI is a bank. But not all banks are SBIs, correct? One, that is child is parent, child is a part of parent, so that we can say that upcasting is possible. Parent object में casting करना possible है, but not always. Or SBI is a bank, but not all banks are SBI, right? सारे parents हमेशा child नहीं होते हैं, कभी ही होते, कभी नहीं होते. Parent is nothing but a common part, right? We are creating the parent classes for just to create one common data, to store the common data for the child. Same here, all banks are not SBI. This relationship is a relationship, that is bank is not SBI. Bank is not SBI. Okay. That is why downcasting concept is not supported in Java. If you want to do that downcasting concept, you can do that. Like here we can create this bank reference we have already created, right? I will create one more. Bank B is equals to new bank B1. And we have this child object, right? I'll create one more. SBI S1 is equals to new SBI. Now, these are two objects. So what is the syntax for downcasting? You have to do that explicitly. Okay, child object and then the parent object using child reference. So here, SBI S1, instead of initializing it through this, we can use this B1 reference and you can cast it to child SBI. Okay, this concept is downcasting. This concept is downcasting. So S1 dot, suppose I am displaying calculate home loan, and we'll display this here, as well as I will display the statement system.out.println as one object. Okay, we will execute this and we will see the output. So what we are getting for the statement, class cast exception. Okay, class cast exception, because SBI cannot be cast to bank. Sorry, bank one cannot be cast to SBI class. Okay, so that is why we say downcasting is not supported in Java. Downcasting is not supported in Java. What is the reason? Inheritance is based on easy relationship. Easy relationship. So in this example, you can say all bank, SBI is a bank. Child is a part of parent. SBI is a bank. But vice versa is not true. That is, all banks are not SBI. This statement fails. That is why downcasting is not possible. We cannot cast parent object into child object. Clear? Understood this concept, upcasting and downcasting? Any doubt? Okay. So upcasting, downcasting, when we just revise, when typecasting of a child object into parent object, it is known as upcasting. When a parent object is typecasted to child object, that is known as downcasting. Downcasting cannot be implicit. Upcasting can be implicit. So this syntax which we have used here, that is bank B1 is equal to SBI, it is internally casting it similar to this. Okay, ऐसे ही cast होता है. तो उसमें आपको कुछ करने की जरूरत है. This can be implicitly casting is implicit. Okay, जैसे कि हमने टाइप कास्टिंग में वाइडनिंग देखा था, वाइडनिंग is implicit, but narrowing should be explicit. Same here, upcasting is implicit, downcasting you need to do explicitly. Okay, but it is not supported. Next is topic is has a relationship. We have seen that this is a relationship. Inheritance is a relationship. Okay, now we are going to see has a relationship. It is known as association. What do you mean by that? Association is the relationship between two separate classes which establishes through their objects. Okay, we establish the connection, we establish that relation between two different classes using the objects of that class. Okay, that is known as association. Association can be one to many, one, many to one, many to many relationships are there. These relationships we use in SQL tables also. There are relationship between SQL tables similar to this. Okay, so if you understand this association concept here, you will be able to understand the relationship concept in SQL also. So association can be one-to-one relationship, one-to-many relationship, many-to-one, many-to-many relationships. Okay, so this association is known as has a relationship. There are two types of two forms basically of this association, composition and aggregation. What are these two forms that we are going to see? So basically, composition is the middle part, aggregation is a wider part, and a complete composition and aggregation is known as association. In Java, has a relationship essentially implies that an example of one class has a reference to an occasion of another class or another occurrence of a similar class. What do you mean by that? That we will see through example. First, we are going to see the aggregation concept. Okay, aggregation. In a simple example, if I have to tell you what is a has a relationship, I will create one class here that is has a relationship. including a main method. So we have seen one vehicle and car example. Right. Vehicle and car example, right? So car is a vehicle. Car is a vehicle and all cars will have engine. So all cars or all vehicle will have engine. I'm considering car here. Car has a engine, right? Car has a engine. Engine is a part of car. So here we can create the association, relationship between these two. How? That we will see here through aggregation or composition parts. In association, this is the special form. It represents has a relationship. It is always unidirectional association. That is a one-way association. Okay, one-way relationship. From one class to another class, there is always a one-way relationship. For example, a department can have students, but vice versa is not possible and thus unidirectional in nature. Okay, that means one class has students, but without student, class will not exist. Without students, department will not exist. So basically, if we are saying that it is unidirectional, it is a dependent in nature. Both entries can survive individually, which means ending one entity will not affect the other entity. Okay, यहाँ पे हम department can have student, but vice versa is not possible. Similarly, in aggregation, both entries can survive individually. They can survive individually, but they, which means ending one entity will not affect other entity. Okay? So the same example I'm showing here. Students, college has student. Okay, college has teacher. If they are leaving, student is leaving college, teacher is leaving college, they can survive. They can survive individually. Teacher class will survive, student class will survive. They can perform their own operations. College class will also survive with the to perform any operation. Together they are forming aggregation relationship. Okay, that is unidirectional relationship from teacher to college, student to college. Okay. It is also known as weak association. It is a weak form of association. Second one is composition. Composition is a restricted form of aggregation, as we have seen first diagram, where composition is a part of aggregation. It is a restricted form of aggregation in which two entities highly dependent on each other, highly dependent. It is a part of relationship. It is not known as has a relationship. It is part of relationship. In composition, both entities are dependent on each other. Both entities are dependent on each other. Where there is a composition between two entities, the composed object cannot exist without other entity. Like vehicle has engine and vehicle has a tire. Without tire, without engine, vehicle will not work, right? So that is why vehicle is totally dependent on tire class. So vehicle is dependent on engine class. That is why this is composition and part of relationship, because tire is a part of vehicle, engine is a part of vehicle, right? So this is composition where two entities are totally dependent on each other. They cannot exist individually. Without vehicle, tire will not exist. What is the purpose of tire? Without vehicle, what is the purpose of engine? Nothing is there, right? So that's why they are totally dependent on each other and they cannot exist individually. They have to work together. This is a part of relationship. If you have noticed the UML diagram, here this square is filled because it is a composition, and in the aggregation, it is empty because this is a weak relationship, weak association part. They can survive individually also. That's why they are aggregation. They are specifying aggregation. with these entities. Okay. This is known as a strong association. Composition is a strong association. Okay. So we are going to see two examples. First for the aggregation and second one for the association. For that, I am creating package under the module 10 package. Name of first we are going to see the aggregation example. Okay. So package name is aggregation. In this aggregation package, we are going to create class. First, we will create institute class. I'm not including main method. We are only writing some members of this inside this institute class. For example, institute has a name. Okay. So first member will be string name. Now institute will have departments. Okay. So for departments, I'm going to create another class. Okay. For department, I'm going to create another class. Inside new class name is department. Department will also have the members like department ID, its name, right? So we will write integer, department ID, string, department name. Okay. This department will have students. Department will have students. So for students, I am creating a separate class. Name student. This class will also not including any main method. So this student class will have student related information like ID, name, address, division, etc. So we will write down those. Integer ID, string name, then string address. Okay, I'm keeping these three only. So this student class can survive individually also. So what we will do in this student class, we will generate first default constructor. We will generate parameterized constructor with all these three, and I am generating toString method. Okay. Now these members are not private. These are all public members, but still I will make them private, and we will generate the getter setter methods for these three members. Your source, generate getters and setters for all. Okay. Now when you create such type of class where you are creating constructors, it can be default constructor or parameterized constructor, any constructor, getter setter methods, toString method. This class is known as Pojo class. Okay. Plain Java object. Okay, this is plain Java object class. This is known as Pojo class, or we can say that it is entity class also, because in this class we are not defining any specific methods. This is only defining a one student record or multiple students record. It is like a template. Okay, we are not writing any main method. We are not executing from this class. It is just a template. That is why this type of class is known as plain old Java objects, basically. Pojo classes. Okay, as well as these are also known as Java bin classes also. Okay, Java bin classes. But there is a small difference between that. When we learn the Java bin type, that time we will see that what is the difference. But most of the time we use the same terms. For Pojo class and bin classes are same, where the members of the classes are private. Any constructors To access the private members, you can write the getter setter methods and a toString method. Apart from that, I am not writing anything here. Okay. So for all these three members, I'm giving some default values. So we will use this here for calling the parameterized constructor with values like 101, name, and address. Okay. We don't require this super. I'm removing it. So this is a basic Pojo class, student class. Now coming back to our department class. Department has its member, that is department ID and department name. As I said, department will have students. So now how will you create a relationship between these two classes? How will you create a relationship between these two entities? Just by creating object of the student. So multiple students. Okay, department will have multiple students, not a single student, right? Multiple students. That's why here, what we will create? We will create student classes array as a member of the department class. Students as the name. Okay. So here department will have multiple students. Department has students. We can say will have, instead of will have, department has a multiple students, okay. So here we are creating has a relationship between department and student class. How we are creating? We are creating it through creating the object of that class. Okay. If there is a one-to-one relationship, this is nothing but the one-to-many relationship. Why? Because one department will have one department, many students. Right? One department has many students. That's why one-to-many relationship we are creating it through using student classes array. Okay. So in this class also, we will generate constructors using fields, constructor, default constructor also. Then we will generate getter and setter methods for all, and we will generate toString method. Okay. This is again same as the Pojo class. This is also known as Pojo class, you can say. Okay. Here I'm changing in department, we will set some default values. Now, when you are trying to display the arrays class is there, and there is a toString method of arrays. So this arrays.toString method displays all the string data from your array. Okay. So if you want to display array, you can use this method also. Arrays.toString. Arrays is a class, predefined class. So in this default constructor, we will set data for ID. This dot ID is equals to 101. This dot name, let's suppose ENTC. Okay. And for students array, I'm going to initialize this array here in the default constructor. Students is equals to new student. I'm defining or initializing it to 10 size, maximum of 10 size array. Okay, that's it. So this is department class is created. Here we are seeing the aggregation concept where this department has multiple students. One department has many students. That is why this is nothing but one-to-many relationship. Now coming back to our institute class. As we have seen, institute has one member, that is name. And institute has multiple departments. Institute has multiple departments. Again, one institute, multiple departments. So one-to-many relationship here. One-to-many relationship. So how will you create a one-to-many relationship? This one institute will have multiple departments. Again, for multiple departments, you have to create department classes, array is equals to, okay. We will initialize it again into constructor. So same thing here. I am generating first constructor, then parameterized constructor, then getter setter methods for both, and a toString method. This is again Pocho class or bin class. Okay? This is also same institute class. We are not going to do anything or add anything here. This is array. So we will initialize that array here. We will set some default name. This dot name is equals to, suppose that name is 2n. Okay, and we will initialize departments array. Departments is equals to new department type of objects we are going to save. Here also I am going to add maximum of 5 departments. So I have initialized to size 5. Okay, now our basic structure of a HACCP relationship is created. First, we have created student class, then department class. Department has multiple students. One department has multiple students. One institute has multiple departments. We have generated, we have created one-to-many relationship in institute and department class. So between institute and department class, and department and student class. Okay. Now we will test this through one tester class. So this aggregation, this is a weak relationship, weak association. Institute can survive without departments. They can add any department they want. If they can remove any department they want. So department is not necessary. Student can survive individually. Department can survive individually. Anything. So this is weak association, and this is aggregation part. Okay. So here we will create class test aggregation. In this class, I am including main method. Okay. So in the tester class, first we need to create students, because first we have to admit the students. So here also I am creating student array, name students is equals to new student. I am creating maximum of 3 size array. Okay, not more. I'm not going to take inputs from the user. You can use any default one. So I'm going to show you one statement here, that is one small syntax. I'm going to create the students manually. So this will use for loop to add students. We have to initialize each student object. So we will use students of ith index is equals to new student with default. Okay. And here, now I'm going to set some details like students of ith index dot set ID. ID we are going to set with I variable value itself. Whatever the I value you are incrementing, that will become its ID. Then students of ith index dot, we have to set name. right? So for setting name, I'm going to use here I variable value itself, and whatever the character present at I, I'm casting it to char, and then I am appending the data name. Okay. So our student have only this. Okay, we have address also. So I will add address in the same way. I'm generating this basically. You can take the input from the user and all those things. I just want to show you the execution of this. Okay, so our basic 3 students data is created. In a similar way, if you want to see the data, you can display it. System.out.println. Students. After students, we can display it using for each loop of students and system.out.println. Each student object we will display. We have already included the boosting method, so we can be able to see all these data in the same. Then we will create departments. System.out.println. In the same manner, department array departments is equals to new department. I'm creating only 2 departments. So first departments at 0th index is equals to new department. Here I am going to use this department parameterized constructor. First department ID 1, department name. And now here we are going to pass the same array of students here as a parameter, so that this students belongs to this department, 0th department, that is whose name is mechanical. Okay. Now departments of first index, I'm creating a new department. Here we need to set the students. Okay. This is a default department constructor where we have set the name and department ID, and we have only initialized the object, array. We have to set the students. Now we have already created this students. You can use the same students or you can create new students also. I'm going to use the same students. Okay. Same pair of students for both mechanical and both this department, E&D's department, or you can use another one also. So department of first index dot set students. You can set here students directly, or you can keep it null also if you don't want to set the students. In similar manner, we will display all the departments. Departments, and here also is the object name. So our departments are also ready. Last one is institute. So we will create one institute object is equals to new institute. I have already set the name and data here. So we are using default constructor, and we will set institute dot set departments, and we will set this departments. System.out.println. Now we will display institutes. Institute information, system.out.println. We have created a single object. We will display that. Now I'll execute so that you will understand. So this is the first students we have created. Okay. Right. Character is not. Okay. Some problem is there. It is not displaying the characters. 0, 1, 2, 3 students. We are setting these 2 students to the department. So you can see that department has these students. Okay, all 3 students I have assigned. For department 1 also all these 3 students. So basically we are creating, and this institute has these 2 departments, mechanical and with the students data you can see here. Okay, ENTC department. So this is basically we are creating relationship between different classes using their object. Okay, clear aggregation concept? Anyone has any doubt in this? Understood the aggregation concept, right? You just have to set the details according to your need. Here we have created multiple parts. Okay, these are multiple, many one-to-many relationship is there. That is why we are creating arrays. If there is a one-to-one relationship, you just have to create a single object. Now we will see the next example of composition. Next package I am using composition. And this composition package will create class we'll create a book class. This is a Pojo class. Okay, we will create members like private int book ID, private string, book name, and private double price of the book. I'm not adding any other thing. If you want, you can add. Generate the constructors. Source generate, parameterize and default constructor, generate the getter setter methods and toString method. Okay, this is a Pojo class, book Pojo class. We have generated everything. Now, second is class library. Class library. This library class have books. That is, library has books. So here we are creating only books array. The member of this library class is books array. Okay, we will generate all the details like constructor, default constructor, parameterized constructor, getter setter method. Now you can set the getter setter method for array also, and toString method. Okay. Here only we will initialize this books is equals to new book of 10, maximum 10 size array we are creating. Okay, so book is individual, library is without books, library cannot exist, right? So this is a strong association between books and library. Without books, library does not exist. So this is strong association. We are creating this through composition. Okay. Now to test this, we will simply create one tester class, test composition. In this class, I am including main method. Now, as you know that, we can create first library reference, new library. This library will have books. So we have to create a book array. Books is equals to new book of, I am creating 3 books. Okay. Here you can take the user inputs also. Now I'm going to write this manually. Okay, manual data. So here first books of 0th index is equals to new book with the data book ID 101 book name Java programming, then price. Similar to this, we will add 2 more books into array. Books at first index, books at second index. Book ID is changed and this is also changed. Value is I'm changing. Okay, so our books array is created. Now you can display the books if you want, or you can use this library. We can set all these books using l.setBooks. Just pass this books array. Our library has all these books. You can display books in library. Use for loop, for each loop. We don't require this. We have already created a single reference. The system.out.println, this L object we can display. So we can see all the books inside library. 3 books. Okay. So in a similar way, you can create another, you can set another book set of books also to this library. Library have multiple books. So you can set multiple books to this one library object. So again, this is also one-to-many relationship. And this is a composition part because they are strongly bounded together. Okay, clear? The concept of aggregation, concept of composition, any doubt in this? This is has a relationship. Any doubt, anyone? Clear with this? Okay. Last part of the inheritance chapter or module is final keyword. Final keyword is a non-access modifier as same as the static. It is applied to variable, method, or class, and it is used to restrict a user in Java. Okay. So when we create final variables, that means when you want constants, create constants, that value does not change, never change. Once it is set, that should be for permanent, right? So you can declare that variable as final variable. It is declared as final when then we cannot change its value. Okay, once it is initialized, it has to be initialized at the same time. This is useful for declaring constants. Second one is okay, final is a keyword you have to use, then the data type, and then the name of variable, and then its value should be initialized. Second, we can apply final keyword to the methods. The method declared as final. When we declare method as a final, that method cannot be overridden. So basically, it is used for restricting overriding part. The syntax is like final keyword with the method definition. Okay. If we are defining this method as final, this cannot be overridden into child class. Last final keyword we can apply to the classes. So when the class is declared as final, it cannot be extended. When you want to restrict inheritance for a parent class, then you can restrict it using final keyword. So when you are declaring that class as a final, it cannot be extended. Inheritance is not possible. Okay, so this is useful for classes that are intended to be used as is and should not be modified or extended. So the syntax is using the final keyword, class, and then the class name. Basic, all the things you can write inside this class. Okay, we are going to see the example of this. So in the module 10 package, I'm creating another package, final. Okay. Inside this, I am creating first example. We are going to see for final variable, including the main method. Final int x is equals to 10. Okay, when you are defining any final word, this value cannot be changed. If you try to modify it, 63, this is not possible. It will give you error. So when you assign any value to any variable and making it final, the value never changes. Okay, system.out.println x is equals to the value is x. Okay, value of x, you can add it here. Similar to this, you can define final variable with static also. Final static double pi. Okay, the value is 3.14. This is fixed. So when you are declaring this final variable here, that means this is a local variable. If you are defining it as a class variable, that is a class variable itself. Okay, when you are defining it with the static, that means only one time memory allocation will be there. It is loaded at the first, gets loaded when the static block gets added, right? Static memory allocation जब होता है तभी इसको memory allocate होगा, and value is also assigned at the same time. If you thought that you don't want to give value at the same time and you try to give the value here, it is not allowed. Okay, when you are using final keyword for static, you can do that. You can declare and define later. You can initialize the value later. You can modify the value later. But when you are defining variable as final, you have to initialize it at the same time. You have to specify the constant value. This is nothing but a constant. We never change its value. Okay, so we can use final and static keywords together to make any constant variable. Clear? This is a final variable. Any doubt?
So can we use final constant, or final itself is working like a constant?
Yes, final itself is working like a constant. If you are giving any value to it, it is never going to change. If you are declaring any value, that is fixed. Some rules are there when you are defining final variable. It should always be in the capital case. Okay? It always should be in the capital case so that it should be constant. We should understand that it is constant. Okay? It can be local variable. It can be class variable.
It can be attached to the class. Okay. I think constant, this is a major difference. Constant, I can put it for only variables, but this final, we can add it for class, function, as well as variable.
Yes.
Okay.
Final keyword we can add, it is a non-access modifier, same as the static. We have applied static for the variables, for methods and blocks. Similarly, final keyword we can apply to variables, methods and classes. Okay.
Thank you.
Institute. Now I can keep this as final institute string institute name true, which is not going to change anytime. Okay. So this is nothing but class variable. Okay. This is a class variable. Because we are adding static here, so memory one allocated only once. This is an instance variable, and this is local variable, right? Because we are defined it inside main method. So you can apply final keyword to any type of variables. Okay. Now, if you want to access this instance variable, you need to create the object of this final variable. And then you can access it f1.institute. Okay. We will declare it. Okay, we can display it system.out.println. It's not accessing basically. Let me check. Okay, I'm displaying it system.out.println. So institute is accessible. If you remove this, here it is accessible. No. Why? Because main method is static method and we cannot access non-static members. Okay. So if you want to access instance variables, you have to create the object of that class. So you can apply final keyword to any type of variable. It can be class variable, it can be instance variable, or it can be local variable. Static variables are always class variables. We never apply static keyword for the instance variables or the local variables. We never apply, we cannot apply, right? So for local variables, you can add, we will check here. So it is not allowed. Okay. So if you are using, if you are defining local variable as static, it is not allowed. You must have to write the static variable as a class variable itself. Okay. It is known as class variables. But final keyword you can apply to any type of variable. Clear? Okay, then we will end our session for today here. We will continue with the final method and final classes in the next session. Okay. And then we will see next part. So with the final keyword examples, we are going to complete your module 10 and we will coming back to your module 9 with the abstraction concept. To understand the abstraction concept, you must understand first all these relationships, overriding, and the inheritance types. Okay, so that you will be able to understand the abstraction concept.
Okay. Ma'am, in the notes, the module 5 notes are missing.
I have already shared the module 5. So I shared from 6, 7, and 8 module. Once we complete the module 9, I will share within some days.
Because module 1 to module 4 I have downloaded. Module 6 to 6, 7, 8, 9. Those things also I have downloaded. Module 5, I'm not getting it. Okay, anyway, I'll just check it in the chat box. One second.
1 second.
Yeah.
I'm checking it immediately. Okay. So that.
Okay.
Module 4 I have shared on in the June.
Yes.
Okay, I think I.
5 is missing. 6, 7.
Okay, yeah. I will share that.
Okay, okay. Yeah.
Again.
Thank you. Thank you. Thank you.
Module 6, 7, 8 I have already shared. Once we complete the module 9, module 10 first I will share. Module 9 I am sharing once we complete the abstraction part. Okay. And those who have not completed the assignments, please complete the assignments. I am uploading the new assignments within this week. so that you can go through it and you can add, complete those. Okay. Thank you, everyone.
Yeah, thanks, ma'am. Thanks.